Hello. This is your DXF file. I opened this up in DraftSite. It's like an AutoCAD program. Um, and what I wanted to show you here, I'll do a linear dimension, and we'll just do the extents here. Let's see. We'll go from like here to the farthest point on the opposite end, which is here. And if we take a look at our number, we have 1390.17. Okay, so I imported the CAD into PyroSim, and I have the DXF file here, and we can take a look at it. Okay, so I'll go to 2D view and do a front view, which we have here, top view, and I'll measure, do the same. So you can use the measure tool. We'll go from 0, 0 all the way over to here, and actually 1390.168 is the correct number. It rounded in the dimension of DraftSite, so I'm going to cancel that. And if we actually go back to this, and I think it's in here where I can change the, here. Let's go out to 4. We can see we get the 168. So it's the same size, so I know that the scale is correct. So that was the first step. The next step is I created one mesh that was around everything. And then I split that mesh using this split mesh tool right here. I split it right at where the tunnel bends up, so this flat spot, and then I pulled the mesh boundary down here. So let me just go through that process real quick so you can see how this works. One thing that I wanted to show you though is that you have to have meshes to be able to have any records. So right now I have this mesh disabled. If I enable it, so if you look in record view, it's just some time records and that's it. And if you were to look at the FDS file or preview FDS, you would see nothing is here because there's no mesh to render this geometry against. So if I enable these meshes, now if I preview, I'll see the blocks. These are the blockages for FDS, and the whole tunnel is resolved. And if I switch back to record view now, I'll see a lot of obstructions used to define that tunnel shape. And if you export this to FDS, write an FDS file, and we take a look at that here, we'll see all of the files, all the lines. So you have to have meshes to render or sort of convert geometry, non-rectilinear geometry. Now if you just drew an obstruction or a plane or something that was axis aligned, the way this works, you don't really need a mesh to render it against, so they will sometimes show up if it's on axis. So if I just drop a block in here like that, I have this obstruction now. If I go to the record view, it's right here. If I turn off, if I disable this, I still have that obstruction because it doesn't need to be converted into geometry. So that's how that works. I'll get rid of that. Okay, so I have my 3D view. I'll enable meshes, and now I see all my geometry. So I'll turn off preview. Now the way I did the meshing, let me delete this. Yeah, I want to delete that. So and again, here you'll see preview, everything disappears. So double click meshes. I come up to the mesh dialog. I want to make a new one. It automatically tries to fit fairly close to the geometry. It kind of creates that similar sort of bounding box geometry, but this is not the closest fit. When it starts out, it tries to create quarter quarter meter cells, which in this case are probably way too small. You have about 30 million grid cells here. That would take a computer that has at least 30 gigs of RAM, probably more with this kind of a model. So you're looking at somewhere at least 30, probably somewhere closer to like 40 or 50 gigabytes of RAM to run this simulation with this number of cells. Now another option is you can divide this up into multiple meshes, and then you can run multiple meshes on different computers as a cluster, and then maybe each computer takes 10 million cells, and then it only needs 10 or 12 gigs per computer, or 16 gigabytes or something. So, there's different strategies on how to model, but probably in this situation for this tunnel you're looking at more general flows, and you can get away with probably half meter or meter cell. So in this case we're just going to leave this because I want to show you how this works. So we'll go ahead and say OK to that. Now I have the mesh selected, and I want to start actually moving it to fit the geometry better. So the easiest way to do this is in the 2D views, and we'll just zoom in here, and we can see that I have a few cells past this end of the tunnel that I don't necessarily need. So you can grab this and just pull it in and snap it to the end. Now I'm going to do the same thing with the bottom of the tunnel. So I'll zoom in down here, and I see I've got a few cell past the bottom, so I'll just go to this one, and then we'll make sure on this other end that we are ready. Yep, so I can pull down to here and over to there. Okay, now I'll do a top view. We'll go this view, front, and I'll go pull this down and push this up. Okay, and then check the other. There we go. Okay, so and one thing I notice here is that I think it was drawn, the XYZ is off a little bit. So I noticed that the Z direction is coming out of the model, this toward us is positive Z. X runs along the length of the tunnel, and Y is your height. Well, in PyroSim, Z is the direction, the gravity direction. Now we can probably change that gravity vector, but what I will do instead is just grab everything and rotate it. So let's go to the view that we want here. No, let's go to this view. Okay, so here we can see Z is up here, is in this direction. Y is this way and X is this way. So the first thing we'll do is we'll rotate all of this. We want a 90-degree rotation. So there's that. Oh, nice. I just have the mesh. Let me grab everything, including the mesh. So I have it all selected here. Now we'll rotate. So I'll start here. We give our reference direction here, and then 90-degree angle there. Now I'll drag, I have all of this still selected. Let's get this stuff again. And I'm going to move it. You can just grab a point here and go to zeros. Okay. So there I've got that shifted. And now let's take a look at the front view. That's fine. Maybe you want the bottom of your tunnel to be at 0. So you can do it this way. Same kind of a deal. And we'll move. And we'll start with this point here. Move it down to 0. So you can move the model around and rotate it. So now X direction is along the length of the tunnel. Top view is the top of the tunnel. There we see it. And then front view, or left side view, is looking in the left end of the tunnel here. Okay, so now we'll go back to the 3D view and look at everything here. So now it's this 3D view is always in a top view. So we're in top view, but we can rotate around, see our geometry, and our mesh is there as well. If you can toggle different views of the mesh here, so we can see what's going on. And what I want to do now is I can hit the G key and click the mesh, or you can pick it in here. Right click, say refine mesh, and I want to coarsen the mesh by let's do this by a factor of 2. So this just changes the cell sizes from 1/4 meter to 1/2 meter, and you can see the reduction. We went from 30 million or 26 million to about 3 million. This is something you can do on a computer with at least 4, 8, 16, something like that gigs of RAM. So we'll say OK to that. And now if I take a look at this, there I can see, I can see my geometry is being rasterized. So that's nice. That's working at least. And then one thing that we might want to do now is we might want to split this mesh just to get rid of any extra grid cells. So all of the cells above the tunnel here will be used, will be part of the simulation, and everything below will be used. So to get rid of a large portion of this, let's go into the 2D views. We'll go to a front view here. And now what I will use is the split mesh tool. So I can hold the G key on the keyboard to get the grid. And now I can bring the split tool in. We'll cut it right here on this one and on that end, and then let's look over here. We'll cut here. Okay, so now I right click and say finish, and I have 3 meshes now. You see mesh A, B, and C. So mesh B is the one that we want to change. So I'm going to pull this down to here. And let's see, yep, should we have just about one cell close, and if I preview, I see it fills that cell. So that's what we want there at the top of the tunnel. And now you could go through and continue to refine this and split, split here, and then pull this box down, and you can try to align this as well. Now, but what we've done here now is if we go into the meshes and we look, the total number of meshes in this model, we reduced that by about 1 million grid cells, a little bit more. So we were at 3 million something before, and now we're at 2.2. So we've reduced pretty nice. So that's a gigabyte of memory we've just saved by just pulling that center piece down. So that's the way that you can do refinements, splitting, and coarsening meshes. And like I said, you could come through here and split again here and here. You could do some sort of a pattern here with your splits. And now finish that, and then pull each of these segments down. So it's easy, just the G, click, grab, pull. Maybe you come to here. It sometimes helps to zoom in a little bit before you get too far along. Like that, and then G there, and you can push this one up. Now what you want to be careful of is, so see this one, it pushed up too far. You want at least half a cell or more above and below your tunnel, so that when the tunnel rasterizes against this grid, it will fill the shapes. If you snap it too close, you can lose that shape. So we'll do this one end of the tunnel and see what the reduction is. So this is already at the top, but this bottom can pull up. So we'll grab this, and we may be able to get it. Yeah, we can get another cell there. And then the last one. And that's, I think, yeah, maybe we can go up one more. Okay, so there's this end of the tunnel. Now we'll take a look at our meshes. We're down to 1.6 million. So the other nice thing about this, doing this meshing scheme like this, oops, I forgot to push this one down. Let's take a look now. 1.6, okay. So the other nice thing about this is if you need to refine a particular mesh, let's say that I have some phenomena that's happening in this segment of the tunnel and I really want it more well resolved. You could come in and just refine, double this one, and now I have a finer mesh here. But I'll leave that coarse for now. So that's it. That's a method for doing refinements and fitting the mesh to the geometry. Now another option entirely is if you just made the tunnel straight, so it didn't have this bend and rise at the ends, and you just left it completely straight. You could go through and for this segment of the tunnel, you would want your gravity vector at this angle off of normal. So normal is straight down. Now if you can imagine if you bent this flat but you wanted your gravity vector to still be in this angle, then it would be essentially this angle off of normal would be the angle of your vector down. So you can change the gravity vector along the x-axis so that this segment of the tunnel has a gravity vector that keeps it pointing perpendicular to the tunnel surface floor, and then this segment it would just be vertical on this normal gravity vector with z negative, and then this segment would have the vector perpendicular to the floor of this section of the tunnel. So you'd set up your vectors so that they are changed along the x-axis, and you set that here. So you can have a constant value, but if you do it from table, you can do that here, where now you can have a gravity ramp over the distance, and you want your x position to be the function. So along the x, the gravities, your y would be constant, and your x and z, which would be a constant at 0. But your x and z directions, as you move along the x-axis, your z and your x magnitudes would change to match your angles here. So you can, this is how you specify that by using gravity ramps. And then you would have just one mesh that went from one end to the other that was fit perfectly to the tunnel, didn't have any extra gaps, and as your flow would flow through this portion, the gravity angle would change and the buoyancy force would move, it would change the buoyant force and flow up the tunnel like it should. So that's another option without having to do your geometry, sort of to reflect the real world, and to use a little bit more computational efficiency. You can do it like that. So hopefully this helped show how this works a little bit. If you have any questions, please send an email to support. Thank you.